Welcome to our video on applications of logarithms. In this lesson, we are going to look at compound interest, which is an example of exponential growth, and we're also going to look at investments, in particular future value. So compound interest is used for calculating growth in interest or investments such as those found in bank accounts. This is the following formula we are going to use to calculate compound interest. So A is compound interest, P is the principal amount, so that's how much you are investing in, or the amount that you started with. R is the annual interest rate, is given to you as a percentage, but you do need to convert this into a decimal. N is the number of compounding periods, and T is the number of years. You don't need to memorize this formula. It's usually given to you on the provincial exam, and they are going to give you the same sort of information that is detailed, explaining what each variable means. So again, compound interest is an example of exponential growth. And exponential growth looks like this sort of function here. Y is equal to some A, where K is your base, to the power of something X. So your K is considered the growth factor, which again is your base. So let's do an example of a compound interest question. With these type of questions, I do suggest you write down all the information you know on the side. It helps you organize your information, and it's also easier for you to put this back into the formula afterwards. So our principal amount is given to us over here. It's $1,000. We're also given a percentage of 6% as our annual interest rate, and we can convert this into a decimal by dividing this number by 100. The next part says compounded monthly. That means N is 12 because there's 12 months in 1 year. Now, as a summary for these N values, N could be 1, which is annually. N could be 2, which is semi-annually. N could be 12, which is monthly. N can be 52, which is a weekly. And lastly, N could also be 356 for daily. And N is equal to 4 as well for quarterly. Okay, so because it said compounded monthly, our N is 12 because there's 12 months in a year. So to the nearest tenth of the year, when will the amount be 1,400? This is our A, total compound interest. Which is your total amount with compound interest. All right. So this is our formula, and I'm going to go ahead and put all of our information in. And we're looking for the year, which is T. So A is 1,400, P is 1,000, R is 0.06, N is 12, and then our power is 12T. So we are solving for T, and we have to use what we've learned about solving logarithmic equations to do this. So I want to isolate T. First thing I'm going to do is divide both sides by 100. So that's 1.4 on our left-hand side. I'm going to add what's inside the bracket, which is 1.005. Yes, you may use a calculator to do this. And then from this point, I can take the logarithm of both sides. And I can also bring down the 12t using our power rule. Then I can divide both sides by 12 log 1.005 in order to get t by itself. And then when we plug this into the calculator, you should get t is 5.6 years. So I want to try the next one on your own. Again, I suggest you to write out all your information on the side first, and then put it into the formula and solve. So go ahead and do that, and then when you're ready, press play. So here's the solution to the try it yourself. A principal of $1,500 is invested at 4% annual interest compounded quarterly. To the nearest quarter of a year, when will the amount be $2,500? So your principal is $1,500. Your rate is 4%. As a decimal, this is 0.04. Because you divide by 100 to obtain it in decimal form. N is going to be 4 because it's compounded quarterly. And then lastly, A, which is their total amount with compound interest, is $2,500. So I'm going to go ahead and write down a formula and then plug in all the information that we do know. A is 2,500, P is 1,500, R is 0.04, N is 4, and then we're looking for T. Okay, so the first thing I'm going to do is divide both sides by 1,500. And then I am going to simplify what's inside that bracket. So 1 plus 0.04 divided by 4 is 1.01. On the left hand side, I can simplify this, which is 5 over 3. And then I can take the logarithm of both sides. Then I can bring down the 4t. And then isolate our t by dividing both sides by 4 log 1.01. And this is what we're going to plug into the calculator, and you should get 12.8 years. Moving on to investments, we're going to look at future value. This is a series of equal investments which is made at equal time intervals, and the compounding period for the interest is equal to the time interval for the investments. The amount in dollars or future value, FV, of these investments is determined by this formula here. So P is the principal, which is the amount being invested. R is a bit different than the last one, so be careful here. The rate in decimal divided by your compounding period is your R in this case. N is the number of investments being made. So let's try an example of this. Determine how many monthly investments of $100 would have to be made into a savings account that pays 6% annual interest compounded monthly for the future value to be $100,000. So our future value is $100,000. The amount that's being invested is $100. We want to know what N is. This is asking for how many monthly investments, so we want to know the number of investments. R is going to be the rate in decimal, so that's 6% divided by 100 to give 0.06 as our decimal, and then divided by our compounding period. It says monthly, so that's 12 times in a year. You can simplify this. 0.06 divided by 12 is 0.005. So now let's go ahead and write down our formula and try to plug in all the information that we do know. So our future value is $100,000. P is 100. R is 0.005. We're looking for N. So I'm going to do 100 divided by 0.0005 first, which is 20,000. Then I added the 1 and the 0.005 together. The next thing I'm going to do is divide both sides by 20,000. So 100,000 divided by 20,000 is 5. Again, I want to keep isolating my n, so I'm going to add 1 on both sides. So 5 plus 1 is 6. And then now I'm going to take the log of both sides. I can bring down our n. And then divide both sides by log 1.005. You can plug this into your calculator. So n is 359.2. And we are going to have to round this up, because if we made 359 investments, it won't be enough to cover $100,000 as a future value. So we're going to round up. So the number of investments is 360. The next type of question we're going to cover are loans. So a loan is usually prepaid by making regular equal payments for a fixed time period. Our formula is present value, where P is your interest, R is your rate in decimal divided by your compounding period, and N is the number of investments being made. So for our next example, a person wants to borrow $200,000 as a mortgage to buy a house. The person can't afford to pay a $1,500 a month mortgage. The mortgage will be prepaid with equal monthly payments at 4% annual interest compounded monthly. How many monthly payments will the person make? So on the side here, I'm going to write out all the information we do know. So your present value, this is the amount borrowed in a loan, is $200,000. Our principal amount in this case is how much we are going to pay each month. This is $1,500. Our R is our rate in decimal, which is 0.04, divided by our compounding period, and it says compounded monthly, so that's 12 payments in 1 year. And then we are looking for the number of investments being made, which is N. So here again is the formula we're going to use. And I'm going to put in the information that we know. Okay, so I have to do some rearranging. I just have 0.04 over 12 just to keep it more accurate for the decimal places, because it does affect our final answer in the end. So as I'm going to rearrange, I'm going to multiply both sides by 0.04 divided by 12, and then I'm going to divide both sides by 1500. So again, this is going to go over here through multiplication, and this is going to go over here by division. And then I'm going to have this left over on our right hand side. You can put this into your calculator to figure out what this number is. It's going to be equivalent to 4 over 9. I'm still not going to touch our right hand side. And then now I'm going to move this one to the other side. And then I do want to get rid of this negative, so I'm going to multiply both sides by -1. Just going to continue on over here. Now I'm going to take the logarithm of both sides. So 1 minus 4 over 9 is 5 over 9. I'm going to bring down this negative n. And then divide both sides by log 1 plus 0.04 over 12. And I do want to move this negative to the other side as well, so I'm just going to switch it. And this is what we need to plug into the calculator. I understand that's a lot to plug into your calculator, but again, you do want to make sure that all your decimal places are in there to get the most accurate answer. On provincial exams, they do want you to round to the nearest 3 decimal places, and if you're off by your decimal places, then marks will be taken off. So I would suggest you plug in 5 over 9 and take the logarithm of that, then divide it by 1 plus 0.04 over 12, take the log of that, and then press equals. And you should get 176.6 monthly payments. And then we want to round this because you can't make 0.6 of a payment. So in order for you to cover the entire $200,000 mortgage, it's better to round up, because if you round down, you probably didn't make enough payments to cover that. So our final answer is 177 monthly payments. So please check to make sure that you know how to plug this into the calculator correctly, because if you don't, then you have to reevaluate how you're doing it, and if you need help, please just contact me and I'll try to help you through with that.